Welcome to Simplifying Radicals and Imaginary Numbers specifically for quadratic formula. The best way to use this video is to take notes while I'm teaching, pausing whenever is necessary, and every time we get to a you try, pause and attempt the problems on your own. Press play when you're ready to see the solution with work. In this section, we're going to simplify radicals and imaginary numbers. There are two methods for simplifying radicals. We could use prime factorization or perfect squares. Today we're going to be using perfect squares. So when simplifying radicals, we're allowed to use the following rule. When you multiply inside the radical, you can separate and multiply each thing individually. So some perfect squares you should memorize. Remember that the way to get to a perfect square is 2 squared equals 4, 3 squared equals 9, 4 squared equals 16. Another way to think about squares is the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4. So to simplify a radical, we're going to look to see if there are any perfect square factors, meaning a perfect square, one of these numbers, divides the number in question. If not, we're all done. If yes, we're going to rewrite it using perfect squares and simplify. So this first example, the square root of 4, well, the square root of 4 is just 2. Notice that the 2 does not have a radical symbol over it. The square root of 9 is just 3. Now the square root of 4, is there a perfect square 4, 9, 16, 25, 36, 49 that goes into 24? What's the biggest perfect square that goes into 24? That's 4. So we'll rewrite it as 4 times 6. And then we'll split up our radicals. And what is the square root of 4? It's 2 radical 6. All right, let's look at the square root of 10. Are there any perfect squares that divide 10? No, too big. So square root of 10 cannot be simplified. Last one together, the square root of 75. What is the biggest perfect square that fits into it? 25. So that's going to be the square root of 25 times 3. We can split that as square root of 25 times the square root of 3. Well, the square root of 25 is 5. You try these 3 examples on your own. How'd you do? All right, what happens if we've got imaginary numbers? So let's go and talk about imaginary numbers. The square root of a negative is not a real number. In quadratic formula, we often write no real zeros. But at this point, we could simplify and use the letter I. We often use a lowercase I, kind of italicized. So the square root of negative 5. Now there is no perfect square that fits inside 5, but we could rewrite this as the square root of negative 1 times the square root of 5. And the square root of negative 1 is I. We've got the square root of negative 24. That negative comes out as an I, and then we can deal with that square root of 24. That's going to be I square root of 4 times the square root of 6. So we'll get 2I square root of 6. To simplify a radical with a negative under the square root, turn that negative underneath to a positive by putting an I on the outside. Look to see if there are any perfect square factors. If not, we're all done. If yes, rewrite and simplify. All right, so we've got the square root of negative 4. Well, we'll start by taking out that negative, making it an I. And we know that the square root of 4 is 2. Now, we just don't normally write it as I2. We'll write it as 2I. The square root of negative 9, that's I square root of 9. So that's going to be 3I. Square root of negative 24. So it's going to be I square root of 24. So that's I square root of 4 times the square root of 6. We've done these before. That's going to be 2I square root of 6. We'll immediately start by making that I square root of 10. Remember, there are no perfect squares that go inside, so that is done. We'll deal with that negative first. So that's I square root of 75. So we've got I square root of 25 times square root of 3. That's going to be 5I square root of 3. And you give these 3 a try and see how you did. And that concludes simplifying radicals and imaginary numbers for the quadratic formula.